I'm Professor Trinkle Yuvraj Chendane. Again, we will start with our lecture series that is nothing but a non-conventional machining processes. I welcome all of you again. Let's start with the electro discharge machining. That is nothing but a EDM. Before that, we will cover some remaining part of its classification. Let's do it. Thus, the classification of NDM process, that is a non-traditional machining process, is carried out depending upon the nature of energy. So, according to the energy, your non-traditional machining process are being divided. So, mechanical processes are divided as abrasive jet machining, ultrasonic machining, water jet machining. These are nothing but the three processes which has to be done by using a mechanical energy used. Second thing is electrochemical processes which uses electrochemical energy. Means first the electrical energy and chemical energy. So electrochemical machining ECM and electrochemical grinding ECG. Again, the third part is electrothermal process which uses electrothermal energy. In electrothermal energy, electro discharge machining that we have to see it right now. This is one of the famous process in electrothermal process, EDM. Again, wire EDM, it is not been mentioned over here. Wire EDM is also been one of the famous process. Second one is laser beam machining, LBM, electron beam machining, EBM. Fourth part is chemical process. In the chemical process, it is being divided by our chemical energy, use of a chemical energy, and it is to be classified as chemical machining, CHM. So these are the processes that we have to covered. Let's start with the EDM. As we have seen in the EDM, figure shows a tool material and workpiece material. Let's see, there is a container. In this container, it is filled completely with dielectric fluid. Let's see, this is nothing but a dielectric fluid. In the dielectric fluid, at the bottom part, there is a fixture. Fixture is used for holding your workpiece. And at the just upper part of workpiece, there is a tool which is of T-shape. But let's see, here it is negative terminal and it is positive terminal. Means your tool is given a negative terminal and your workpiece is given a positive terminal. Means your tool is cathode and your workpiece is anode. So this is nothing but an enlarged view of your tool and workpiece. In between the tool and workpiece, a spark is been created. So electro discharge machining is also been called as a spark erosion machining. Means by using a spark, material is to be removed, and such a removing of material is used for the machining purpose. Let's see some things one by one. Here is the tool feed mechanism. Here is a DC pulse generator. DC pulse generator, which is also called as a DC power source. Means your workpiece is attached to the DC power source positive terminal. Tool is attached to the negative terminal DC power source. Means tool is cathode and workpiece is anode. When we start the supply, two means tool and workpiece may comes to contact with each other with the certain space which is been enlarged over here. This is called as a spark gap. In between a spark gap, spark is been created. This spark gap is of 5 micron to 50 microns, means 0.005 to 0.05 mm. If we put such a spark gap, then and then only spark will be created. If we increase that distance, spark will not be generated. If we decrease that distance, there is a tendency that tool will stick to the work. So we have to maintain a proper spark gap in between tool and workpiece. So how should we maintain? If this tool will cut down a workpiece, then spark gap will be ultimately increases. For that purpose, there is a mechanism will be given over here. That is nothing but a servo control gap, or it is also been called as a servo system. Now, what happens in case of servo system? Servo system is nothing but which uh, analyzes the gap, and which is by using a feedback system measures the distance between the tool and workpiece, and it gives signal to the servo system. Servo system takes action on it. If there will be the increment in the distance between the tool and workpiece, servo system again maintain a proper spark gap. It is like when positive terminal and negative terminal comes in contact with each other, that will create a spark. Now this spark is created for removing a metal ions from the workpiece. So let's see, there is a pump is over here. This pump uses dielectric fluid. Now what is meant by dielectric fluid? We will see it later. This using a pump, it will be again flushing over here on the tool. Now this dielectric fluid flushing over the tool, which is what is the purpose of this dielectric fluid, is to ionize the dielectric fluid and make it converted into ions. These ions are converted and metal is to be eroded, and these eroded metals are again removed by such a pump given over here. See? Now, what are the different types of dielectric fluids? Dielectric fluids are kerosene, paraffin oil, transformer oil. So these are the dielectric fluids, means which carry the electricity. So firstly, there are the different advantages, but it acts as a ionization media, which we'll see in the next figure. From the construction point of view, the main attraction of EDM over the conventional machining is that this technique uses thermoelectric process to erode undesired material from the workpiece. Means we will give a thermal energy by providing electrical energy. Again the same figure, cathode negative, anode positive. In the green color part showing positive terminal, that is nothing but a workpiece. In the this gray color part showing a negative terminal, that is nothing but a tool. This is nothing but a dielectric fluid. Dielectric fluid is continuously been supplied by the pump. So construction point of view, we have already covered shaped tool. So tool is required inverted mirror image of that we have to required on the workpiece. We required a power supply or source. We have already discussed we required a DC power supply. Dielectric fluid, we also covered that dielectric fluid required kerosene, paraffin oil, transformer oil for the circulation purpose. Servo control mechanism, we already seen to maintain the spark gap. The distance between tool and workpiece is nothing but a spark gap. For that purpose, we will use servo control mechanism, and of course workpiece. So tool is again the same. Tool is cathode, negative terminal, work is anode, positive terminal. Terminals are connected to DC power supply, create a potential difference between the work and tool, and the distance between the work and tool is known as spark gap. It is filled by the dielectric fluid. So that's it, friend. For working in detail, we'll see in the next slide. Thank you.